welcome to lesson 4A, notes on polynomial operations and exponents. Guys, this lesson is all review. It shouldn't be any issue for you, but we just want to review basic polynomial operations with you today. So first is when we're adding polynomials, we look for common terms. So when I look at this 2x squared and this 4x squared, when I add them, would be 6x squared. Now the 3x doesn't have a like term, so he just drops down. And then you've got -1 plus 7 for plus 6. Again, guys, you've done that 10,000 times, should be an issue for you. Now remember, when we subtract, we have to actually distribute that negative to all three terms. So this really becomes 3g minus 5g squared plus 7g to the fourth minus 2 minus g to the fourth plus 6 minus 9g. And at this point, you go through and you find your like terms. I'm going to go from the highest power to the lowest. Highest is the fourth power. I've got 7g to the fourth minus g to the fourth gets me 6g to the fourth. Then my next lowest power, we don't have any cubics. We do have a squared, minus 5g squared. And then we go down to our single g's. I've got 3g minus 9g becomes minus 6g. And then our single numbers, I've got a -2 and a +6 for +4. I want you guys now to try C on your own. Right, go ahead, guys, and check your answer. Now, on example 2, we're going to multiply. And remember, guys, when we multiply, one, we have to distribute when you have a monomial multiplying into a polynomial. You always multiply your coefficients, so -3 times 4 is -12. And then you add your exponents. So x squared times x squared becomes x to the fourth. So now -3x squared times -6x becomes positive 18x cubed because we added the exponents. And -3x squared times 1 is minus 3x squared. Now, when you've got two parentheses, two polynomials multiplying each other, you have to FOIL. We go first, which is 2x squared, outside, which is plus 5x, inside, which is plus 6x, and last, which is plus 15. Now, if you look, that produced some some like terms that I need to combine. So this becomes 2x squared plus 11x plus 15. Now, there's also the box method, and I recommend the box method when you've got something when you've got a term that's more than 3, or 3 or more, I should say. And the way we set that up is we make a box that is one side is, so this is 2 terms, so I would put 2 terms going down one side of my box. The other one is 3 terms, so we have 3 terms going along the other side of my box. And again, if you don't like this method, you don't have to use it. And to fill out the box, we simply multiply. 2x times 5x squared is 10x cubed. 2x times minus 6x is minus 12x squared. 2x times 7 is 14x. -3 times 5x squared is -15x squared. -3 times -6x is plus 18x. And -3 times 7 is minus 21. Now, the cool thing about this is usually your like terms often end up on a diagonal. So here are my like terms. So my final answer is 10x cubed minus 27x squared plus 32x minus 21. Now, when you have something that's raised to the third power, what this really means is that I'm multiplying x minus 2 by itself 3 times. So that's x minus 2 times x minus 2 times x minus 2. And in order to FOIL this out, I only do 2 things at a time. I'm first going to FOIL these 2 things out, which becomes x squared minus 2x plus 4 times x minus 2. Take a minute then and combine your like terms. And once I've combined my like terms, I'm going to go through now and FOIL this thing out. X squared times x is x cubed Negative 4x times x is minus 4x squared. 4 times x is plus 4x. Then I'm going to do x squared times negative 2 is minus 2x squared. Negative 4x times negative 2 is plus 8x. And 4 times negative 2 is minus 8. And last but not least, I'm going to combine my like terms. I get x cubed minus 6x squared plus 12x minus 8. All right, so now guys, I want you to pause and do these two trimies. And take a minute, guys, and check your answers. Okay, coming on down here, we have the square of the binomial. Remember, guys, whenever you're squaring a binomial, what you're really doing is you're multiplying something by itself. Now, in Algebra 1, we encourage you always to write them side by side, FOIL and combine like terms. However, if you get good at this, you'll recognize that there are actually patterns to squaring a binomial. So if I have a plus b squared, that's equal to a squared plus 2ab plus b squared. And a minus b squared is a squared minus 2ab plus b squared. So if I have x plus 5 squared, this would simplify to x squared plus 2 times a times b. 2 times x times 5 gets me 10x plus b squared would be 5 squared, which is 25. Looking at this guy here, I have 7p minus 2t squared. Well, let's apply the formula. First, we square the first piece, which is 49p squared. Then we do 2 times a times b. So 2 times 7p times 2t gets me minus 28pt. And then plus, square the last piece to get 4t squared. Now, let's take a look at this guy here. 4m cubed minus 3n squared. We square the first piece, which is 16m to the 6th. Minus, we do 2 times a times b, so 2 times 4m cubed minus 3n squared, which gets me 24m cubed n. And then we square the last piece, becomes plus 9n squared. Now this is very useful with a problem like this here, because when I plug into this, first this is my a term and this is my b term when we're thinking about our pattern. Well, 3 squared is 9, plus I want to do 2 times the first term times the second term, and then plus my second term squared. And now I'm going to simplify this thing out. This becomes 9 plus 2 times 3 is 6, so I get 12a plus 6b. And then this guy here, I'm going to FOIL out, and we can actually FOIL out using the same pattern. This becomes 4a squared plus 4ab plus b squared. And when I'm looking at this, I look to see if I have any like terms, and I do not, so that's my final answer. All right, guys, take a moment and FOIL out 3 and 4 using these patterns. Okay, go ahead and check your answer. All right, our next section, we talk about the product of the sum and difference of two terms. If I have a plus b times a minus b, that becomes a squared minus b squared. So when I look at this, I have 4y minus 1 times 4y plus 1. If I were to FOIL this out, I'd have two middle terms that would cancel. But I can shorten this. Again, this is a shortcut by doing the first two terms, which gets me 16y squared, minus the last two terms, which is 1. That's my a squared minus b squared. It works here with a more complicated problem here too. Again, I've got one that's minus and one that's plus, so it's going to follow that process, where I get 5x minus 2y squared minus 1 squared. We'll FOIL that out. This becomes 25x squared minus 20xy plus 4y squared, and then minus 1. And that's my final answer there. So putting this all together, we can use these to help us move a little bit faster through problems. So here I've got a squared term. I'm going to leave the 4 on the outside, where this becomes 9x squared minus 42x plus 49. And then I can distribute that 4 into the equation. So we get 36x squared minus 168x plus 196. So do you see how using those shortcuts can make our lives go a little bit simpler? Here, I'm going to FOIL out that x squared term first. This becomes 6 times x squared plus 8x plus 16. And I'm going to go ahead and distribute the negative 5 here to get minus 10x plus 15. I'm going to distribute the 6 now to get 6x squared plus 48x plus 96. And I have my minus 10x plus 15. Now we combine like terms to get 6x squared plus 38x plus 11. Oop, 111, sorry. Okay, moving right along. Let's talk about exponents. So remember that exponents really just stand for repeated multiplication. So in other words, 3 to the 4th is 3 times 3 times 3 times 3, and x to the 7th is x times x times x times x times x times x times x. So let's look at here. I want to look at my positive exponents first. 2 to the 1 is just 2, whereas 2 to the 2 is 2 times 2, which equals 4, and 2 to the 3rd is 2 times 2 times 2, which equals 8. So as I'm moving along this direction, what I'm doing each time is I'm multiplying by 2. Multiplying by 2. But let's look at what happens when we go backwards. When I go from 4 to 8, what happened here was I really divided by 2. And from 4 to 2, I again divided by 2. So if I'm thinking about what happens as I go along here and I divide by 2 again, what I get here, 2 divided by 2 gets me 1. And then when I divide by 2 again, I get 1/2. And we divide by 2 again, we get 1/4. And then again, 1/8. When we're thinking about repeated multiplication, though, this is like 1 divided by 2 times 2, and this guy is 1 divided by 2 times 2 times 2. So that's our foundation for negative exponents and 0 exponents. So this means that as long as my base does not equal 0, a to the 0 is always 1, and that if I have a negative exponent, a to the negative n is always equal to 1 over a to the n. So, helpful hint, notice when a factor containing an exponent is moved from the numerator to the denominator, or from the denominator to the numerator, is the sign of the exponent that changes. So a to the negative 3rd is 1 over x cubed. 5 to the negative 2 is 1 over 5 squared. So let's just evaluate these now. So 5 to the 0, anything to the 0 is always 1. But negative 5 to the 0, guys, that negative is not attached to the 0 power. This is like negative 5 to the 0 is 1, so I just get negative 1. Whereas here I've got negative 5 all in parentheses to the 0, that guy is going to be equal to 1. So your grouping symbols really matter here. 3x minus 7 all to the 0 power is going to get me 1. 3x to the 0 plus 7 on the other hand, well 3x to the 0 gets me 1. Then I've got plus 7, so here we get 8. Now 2x to the 0 becomes 2, and then x to the 0 is 1. I get 2 times 1 to be 2. So pay really close attention to your grouping symbols whenever you're talking about exponents. Now let's look at some negative exponents. 4 to the negative 3rd power would be the same thing as 1 over 4 to the 3rd, and 4 to the 3rd is 64, so I get 1/64. Negative 3 to the negative 4th power is going to be 1 over negative 3 to the 4th power. Notice, guys, the only sign that changed was the exponent. And negative 3 to the 4th power is going to be 81, positive 81. So I get 1 over 81. Now 5y to the negative 3rd. That negative 3rd power only attaches to the y. So the 5 stays on top of my fraction and the y goes to the denominator. Whereas here I've got grouping symbols around both the 4 and the x. So that negative 1 exponent applies to both. So this becomes 1 over 4x. Now here, I've got a negative exponent in my denominator. That means I'm going to send this up to my numerator. This becomes simply x to the 4th. And here we've got some addition. 3 to the negative 2 would be 1 over 3 squared. And then 4 to the negative 1 would be 1/4. Well, that's the same thing as 1/9 plus 1/4. Well, we need common denominators in order to add fractions. I like 36. This becomes 4/36 plus 9/36, or a final answer of 13/36. A little bit of fraction math for you guys. Blast back to middle school math. All right, I want you guys now to take a minute and look at and do these 6 problems. All right, guys, go ahead and check your answers. Okay, let's talk about exponent rules. So here, if I have x squared times x to the 4th, that's the same thing. Well, x squared is x times x, and x to the 4th is x times x times x times x. When I count all that up, I get x to the 6th. And if you notice, x to the 6th is the same thing as x to the 2 plus 4. So if I have x to the m times x to the n, that equals x to the m plus n. So let's take a look at some examples here. 2 squared times 2 to the 5th becomes 2 to the 2 plus 5, which is 2 to the 7th. Here, y times y cubed times y 4th, well, there's a hidden 1 right here on that y. When I add all those together, 1 plus 3 plus 4 gets me y to the 8th. Now, when you have coefficients, we still multiply our coefficients together. 3 times 5 is 15. And then we add our exponents. A squared times a gets me a to the cubed. C to the 10th times c to the 10th is c to the 20th. So I want you guys to try these 2 questions now. When we work those out, we get 5x to the 11th and 2 to the 7th. Now here on example 10, a to the 6 over a squared, that's a times a times a times a times a times a. I got 6 a's. Over 2 a's, a times a. Well, if you look, we cancel some a's, and I'm left with just a to the 4th. Well, a to the 4th is the same thing as a to the 6 minus 2. So when we divide, we actually subtract our exponents. So a to the m over a to the n is equal to a to the m minus n. So coming down here, let's simplify these. 7 to the 8th over 7 to the 3rd is 7 to the 8 minus 3, or 7 to the 5th. Here, we're going to always divide our coefficients first, which gets me 5. Then I have x to the 4th over x cubed. We subtract to get x to the 1st power. Here, those exponents don't divide cleanly, but they do simplify. So 16 over 18, I can take a 2 out of both. I get 8 over 9. And then the m becomes m 12th minus 10 would be m squared. And then n to the 5th over n to the 5th, that becomes n to the 0. 5 minus 5 is 0. And we all know that anything to the 0 is 1, so I really have 8/9 m squared as my final answer. You can also look and recognize that those are just flat out cancel because they're the same power. So I want you guys now to try these 2 on your own. Go ahead and check your answer. All right, let's take a look at these. Now we're going to write all these using positive exponents only. So what I want to do first is I want to pull anything with a first pull anything with a negative exponent to the proper place. So this becomes 1 over y to the 11th times y squared. And at this point, I can combine those with addition to get 1 over y to the 13th. Here we have 6u to the 5th over u to the negative cubed. I'm going to pull the u to the negative 3 up. So this becomes 6u to the 5th times u cubed. Now combine your exponent to get 6u to the 8th. Here, they're going to switch places. This becomes 13 to the 12th power over 13 to the 14th power. We're going to now subtract our exponents, and we get 13 to the negative 2 power, which equals 1 over 13 squared, or 1 over 169. Here we're going to first reduce this fraction to get 1/4, so I've got over 4. Then move anything with a negative exponent. That x to the 4th comes down, and there's a plain x down here, but on top the y to the 5th is still chilling out, but the y cubed comes to join it. And so what I have now is I have y to the 8th over 4x to the 5th. Now I want you guys to do those 3 on your own now. Go ahead and check your work. All right, let's talk now about the power rule. If I have x to the fourth squared, that's the same thing. Well, x to the fourth is 4x's, and we multiply it by itself when we're squaring something. So that's x times 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 x, which will come down to, when I combine those together, I get x to the 8th. Well, that's the same thing as if I had done x to the 4 times 2. So if I have a to the m raised to the n, that's a to the m times n. Power to a power, we multiply. So x to the 7th squared is x to the 7th times 2, which is x to the 14th. 2 to the 3rd squared becomes 2 to the 6th. And 7 to the negative 1 squared becomes 7 to the negative 2. I don't like negative exponents, so I flip it to become 1 over 7 squared. I can go ahead and evaluate that to get 1 over 49. And then here, m to the negative 4 times negative 5, we multiply those together to get m to the positive 20, and now I don't have to worry about any negative exponents. I want you guys now to try these three on your own. All right, guys, go ahead and check your answer. And this brings us to the end of this lesson. If you have any questions, please come and ask. Otherwise, take a look at the practice assignment. Thank you guys so much.